So now we're going to talk a little bit about factored form. Some of you guys are getting into that, and it's one of the later sections in this unit. So factored form looks a little bit like this, where you have x minus the x-coordinate of, or the x-intercept, and minus the x-coordinate of the x-intercept. Again. And obviously to get there, we need to get two things times together. Now, there's a couple of words that kind of get thrown around quite a bit with this. One of them is factors. One is zeros. And one is roots. And all these things mean the exact, well, these two things mean the exact same thing. And factors are how you find those things. So let's look over here at this problem that we have right here. X squared, y equals x squared minus 12x plus 20. And this is in standard form. And as we know, standard form tells us the y-intercept, right, which can be helpful for graphing things. But oftentimes we're going to be moving from standard form to either vertex form or factored form because there's more information. So to get to factored form, all we have to do is factor it, right? And so in this case, a is 1, okay, which makes our job pretty easy. All we have to do is remember that these follow this form, ax squared plus bx plus c. And we can see that when a is 1, as it is in this instant, then all we have to do is find factors of c that add to b. And so in this case, we have factors of 20 that add to negative 12. And those signs are real important. Okay, so let's look at some factor pairs. So we've got 1 and 20, negative 1 and negative 20, negative 2 and negative 10. 2 and 10, and 4 and 5, and negative 4 and negative 5. And those are all the factor pairs of 20. And then if we look to what they add up to, 1 plus 20 is 21. Negative 1 and negative 20 is negative 21. Negative 2 and negative 10 is negative 12. 2 and 10 is 12. 4 and 5 is 9. And negative 9. And so that's all our factor pairs. And I know because 20 is positive, both of my signs are going to be the same, right? But I do have, and because I know that this one is negative, then this is going to be our guy right here, our factor pair. Now, when a is 1, right, all we have to do is use those factors, these factors right here, as our factors here. Now, so this is now in factored form, and I need to find what the zeros or the roots are. Well, the zeros or the roots are what's going to make y equals 0. And we know from the zero product property that if this piece equals 0, then this whole thing will equal 0. And if we want to find what's going to make this piece equal 0, then all we have to do is set it equal to 0 and solve. So let's look at that. X minus 2 equals 0. So x is going to equal positive 2. And x is going to equal, and x minus 1, x minus 10 equals 0. So x will equal 10. So my two roots, or my x-intercepts, are 2 and 10, and my y-intercept is 20. Okay, and just based off that, I can actually do a fair amount of graphing, though that's not what this is asking for. If you look at this problem over here, it just says find all the zeros. So it's just going to be x equals 2 and x equals 10. But let's look at the graph of that real quick. So I'm going to come over here. So x equals 2 occurs right here, and x equals 10 occurs right here. and y-intercept of 20 is right there, right? Now, based off where these two x-intercepts lie, I know that my vertex is going to be halfway in between. So 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be halfway between 2 and 10. 1, 2, 1, 2, 3, 4, 1, 2. Yep. So that's going to occur right at positive 6. So my axis of symmetry is going to be somewhere along here at positive 6. And I know that because it's halfway in between those two. And if I want to find out where the y-coordinate of my vertex, all I have to do is plug it in. And so I can say y equals 6 minus 2 times 6 minus 10, or y equals 4 times negative 4, which will be y equals negative 16, which is about right there. And then I know my other y-intercept, or the mirror point of my y-intercept is right here. And there is my graphy poo. Beautiful graph. Not really, but we'll clean that up a little bit. Okay. So my zeros are, and my x-intercepts and my roots, those are all the same thing. Let's look at one more problem real quick. Now, so we have our new problem. Y equals x squared minus 16x plus 64. Some of you guys may have already noticed that this is actually a perfect square trinomial because half of 16 is 8 and 8 squared is 64. But in which case we can factor it down to x minus 8 squared. Now, anytime that you have a perfect square in this position, you should always sort of check that. But we'll go ahead and go through the process, although I know that that's what it's going to be. Y equals x minus 8 squared. So I look at this, and once again, a is 1, right? And so I'm just looking for factors of 64 that add to negative 16. 64, that's my C. My B is negative 16. And I can go 1 and 64, 2 and 32, 4 and 16, and 6, no, and 8 and 8. And because this one is negative, I know that both of these are going to be negative. And this one adds to negative 16. So there's my factor pair. Because a is 1, I can skip to the finish and say x minus 8 times x minus 8, and then which will factor as x minus 8 squared. And then my zeros are just going to be this positive 8. X is going to equal positive 8. It's always kind of the opposite of what it looks like. So let's talk about one other problem that's in this group of homework, and that is, and that's when you're given this one. Write a quadratic equation where where the roots are whose zeros are negative 10 and negative 3. Well, so all I need to do is write an equation with factors that will give me those zeros, right? And so if we know that x equals negative 10, right, and we want a 0 that's going to equal negative 10, well, what I'm going to sort of do is solve for 0. So I'm going to just add 10 here. And I'm going to get x plus 10 equals 0 now, Oh look, so that's one of my factors, x plus 10. And then I have another 0 at negative 3, x equals negative 3. So I'm just going to add 3 to both sides so that I get x plus 3 equals 0. And there's my other root. And so this is a quadratic equation whose zeros are negative 10 and negative 3. Now it could have all kinds of stretches and all that kind of stuff, flips and all that kind of stuff. But it will always have those roots. Now you don't need to FOIL it out or anything. You can just leave it just like that. Let's look at one more of these problems. Okay, we want one whose zeros are 6 and 3. Some of you guys have probably already done this in your head because you know that it's going to end up being the opposite of that. But here we go. So my zero is 6. So I'm going to make that equal 0. So I'm going to subtract 6 from both sides. I'm going to get x minus 6 equals 0. And so my factor is going to be x minus 6. And my other factor, or 0, is x equals 3. So I'm going to subtract 3. And I'm going to get x minus 3 equals 0. So then I know that factor is going to be x minus 3. So those things are all real closely related, and that actually ends up being a big topic, especially in pre-calculus, where you'll have things like this that could be pretty big functions or big looking functions like that. This is actually a quartic function, or x to the 4th power, but it will have roots at negative 3, positive 3, negative 2, positive 5, and positive 7. In other words, it's going to kind of go a little something like this, where, let's see, negative 2, positive 3, positive 5, positive 7. It's going to come down and go like this and take off. Kind of like that. Okay. Anyway, so that's a short thing on factors. Let's see if I can